Hello, geometry students. Today we're going to continue on our introduction to trigonometry, and today we're going to be using trigonometry to determine the missing angle measurements inside right triangles. So before we start, we want to recall the ratios from the previous video. The sine of an angle equals the length of the opposite leg divided by the length of the hypotenuse. The cosine of an angle equals the length of the adjacent leg divided by the length of the hypotenuse. And the tangent of an angle equals the length of the opposite leg divided by the length of the adjacent leg. So pause and write these steps down before we go any further. Take a screenshot or pause the video and write these steps down. You're going to need to find your trig button, and this time when you click on the trig button, I want you to notice the bottom row. The bottom row we haven't used before. They are all the inverse functions, and that's what we're going to need to find missing angles. So first, the steps are pretty similar to the last video when we found the missing side lengths. The first step is the same. We have to find which trig function involves an angle, the opposite leg, and in this case, the adjacent leg. Of course, it'll be different for every problem, but in this problem, we have an angle, the opposite leg, and the adjacent leg. Which trig function involves an angle, the opposite leg, and the adjacent leg? TOA. The tangent of an angle equals the opposite leg divided by the adjacent leg. Second step, we write our equation. The tangent of an angle equals opposite over adjacent. Then we're going to use our new inverse operation. We're going to take the inverse tangent of both sides of this equation. We remember from Algebra 1 that as long as you do the same thing to both sides of an equation, you haven't ruined the equation. You have not done anything wrong. You're allowed to do that. And inverse tangent will undo that tangent, and x will pop out as long as we do inverse tangent to both sides. Punch this into your calculator and you will get this answer, and we'll round to the nearest whole degree. Once we know that angle, we know that the two acute angles inside a right triangle are always going to be complementary. So see if you can pause and practice on your own paper, and then press play for the solution. What if we want to find both missing angles? Well, the first step's the same. What trig function involves an angle, the opposite leg, and the hypotenuse? That would be, so sine of an angle equals the opposite leg over the hypotenuse. Second step, we write our equation. The sine of an angle equals opposite over hypotenuse. And now, in order to find that missing angle, we need to take the inverse sine of both sides to solve for x. When we take the inverse sine of both sides, inverse sine will undo sine and x will pop out, but we have to just remember to do it to both sides of the equation. When we punch that into our calculator, we get our answer for x. And once we have x, we can find y, the other angle, because we know that the two acute angles inside a right triangle are complementary. So pause, find the missing angles, and then press play for the solution. Our first step, we have to determine which trig function involves an angle, the adjacent leg, and the hypotenuse, and that is cosine. The cosine of an angle equals adjacent leg over hypotenuse. So the second step, we write our equation. And the third step is we solve our equation. The way to get x alone is to undo anything happening to x. How do we undo cosine? We take the inverse cosine of both sides of the equation. Inverse cosine will undo cosine and x will pop out. We just have to make sure to take the inverse cosine of both sides to get x is 24 degrees. We'll round to the nearest whole degree. And then once we know x, we can find y, because we know the two acute angles inside a right triangle are always complementary. Pause, find the missing angles, and then press play for the solution. Which trig function involves an angle, the opposite leg, and the adjacent leg. That would be TOA. Tangent of an angle equals the opposite leg over the adjacent leg. So now let's write our equation. And third, we'll solve our equation. To solve the equation, we have to get x alone, so we have to undo anything happening to x. Tangents happening to x, we're going to take the inverse tangent of both sides. We know inverse tangent undoes tangent. We just have to remember to do the inverse tangent to both sides of the equation. And then we use our calculator to find that x is 81 degrees, rounding to the nearest whole degree. Once we know x, we can find y because we know that the two acute angles inside a right triangle are complementary. Pause, find both missing angles, and then press play. First step, which trig function involves an angle, the opposite leg, and the hypotenuse? That would be so. The sine of an angle equals the opposite leg over the hypotenuse. And so the second step, we can write our equation. Third step, we solve our equation. We want to get x alone. Sine is happening to x. We have to take inverse sine of both sides of the equation. Inverse sine undoes sine, and x will pop out. And as long as we do inverse sine to both sides of the equation, punch this into your calculator, and you will get that that x is approximately 71 degrees, rounding to the nearest whole degree. And then once you know x, you can find y because you know that the two acute angles inside a right triangle are going to be complementary. So pause, practice both of these problems, and then press play for the solution. For this problem, what trig function involves an angle, adjacent, and hypotenuse? That would be cosine. And so you would set up your equation. Cosine x equals 3 divided by 5.8. Take the inverse cosine of both sides. Inverse cosine undoes cosine, x pops out. Make sure you do inverse cosine to both sides, and you should get 59 degrees. How about over here? We've got an angle, an opposite leg, and the hypotenuse. In that case, it's sine. The sine of an angle equals the opposite leg over the hypotenuse. Set up our equation, take the inverse sine of both sides. Inverse sine undoes sine, x pops out, and we get 24 degrees. And so that does it for finding missing angles using trigonometry. So I will leave you with this adorable kitten and wish you a great day.